When designing a set of icons, one of the first things you should consider is the context in which it's going to be used. Now, the predominant source for icons is typically user interfaces, much like we see here. We've got a whole host of icons in our toolbar here and up in my menu bar there up at the top. Typically in laptop scenarios where you've got mouse level accuracy, you don't have the same considerations as you would have on a handheld device like a smartphone, where the pointing device is not a mouse but somebody's finger. So typically the minimum amount of real estate that you want to reserve for finger interaction is about 48 by 48 pixels. To give you a sense of that, you should really zoom your artboard out to around 8 to 10%. And you can see I've got a series of 7 icons that I've designed here that I'll be discussing. And this typically indicates roughly the size that you would find that on a handheld screen, on a tablet or on a smartphone. As we zoom in, we'll just talk a little bit more about design approaches. And we're just going to take a zoom in here. We'll look at the first few examples. Now, right off the top, the one in the top left here is high realism. So lots of light and shadow interplay, high degrees of detail, very much illustrated. Now, just adjacent to this, what we're seeing now is a distillation of information. We're starting to remove very subtle information that we had in the shading, moving away from high realism, literalism, to more abstraction. And abstraction really means about showing the thing or pointing to the thing with the least amount of information in the most efficient way. Now, we're still keeping the color here, but the thing you should ask yourself is, can you sign the thing or symbolize the thing that you're pointing to, whether that's an object or an idea? And if you stop and think about, what's my idea all about? Well, from Acorn, you might be getting ideas signed like nature, or perhaps growth, or fall, perhaps, because that's when these things happen to fall down, or knowledge. Oaks represent growth, any number of things. Seeding, getting things started. So these are very suggestive meanings. They're not literal meanings. They are more metaphorical. Anyway, we're going to continue that process of abstraction. Now we're removing the color. Now, at any time when you're removing things, we call that parsing or distilling. In that process of distillation or abstraction, if at any time the meaning and significance is lost, you need to back up a little bit. But you can see here plainly in black and white that we can still make out the fact that this is an acorn. Now, you'll notice that I have a particular line thickness here, and there is a minimum at which you need to work. And the grids that I have provided, each one of these pixels that we're seeing in the grid is the equivalent of 5 pixels on your screen. So in order to generate these lines that we're seeing here, you'll notice that they're all set at 5 points. Points equal pixels on an iOS or a Macintosh screen. They've been designed that way from the get-go so that they would harmonize with the typography systems that we've all grown up with in the graphic design and print industry. The point system is such that there are 72 points in an inch. And it's no coincidence that when Steve Jobs and Steve Wozniak at Apple were designing the very first Apple Macintosh, one of the objectives in the design of that computer was that it would have a graphical user interface, or GUI, that would render beautiful type much in the same way as typesetting systems would at that time. So they felt it was important to use the same measure on screen as you would use in regular typography in the day. So we now have on a Mac screen 72 pixels or points per inch. So that's why I've made these things this thickness. It has to be a minimum of 1 grid pixel in size. And the reason for that is if things are any smaller than that 1 pixel minimum, then they might cease to even be represented when they're brought onto a handheld screen. The line work would just simply not be rendered. So we have to be mindful of that. And I'll just zoom out for a sec and move along to the next example. Now, this first abstracted black and white example that I've shown you, it would just be called graphic black and white. This one, or outline, is another name that it's referred to, particularly in the Google Manual of Material Design. This would be considered solid. We could also call it reverse. You can see why. These typically have more impact than the outline versions simply because they occupy a greater degree of graphic mass. And graphic mass is essentially, if you were to add up all of the pixels that were colored in black, that's your graphic mass. And if you calculated that as a percentage of the overall area, that would give you, the degree of visual signature or strength of that visual. This obviously would give a weaker signal, this a stronger one. Now, it's always good to leave a little bit of breathing room around your graphics. Make sure that your graphics are properly centered within the grid system. And in this case, I've used 10 grid pixels as a minimum amount of space from the edge. The next example is two-tone. So we're using grays and outline forms. It's not quite as solid, not quite as strong a visual signal. However, it can be effective in some cases. Now, in terms of rendering things in the process of abstraction, I've used what we call a sharp rendering. This is where all of the edges are sharp and angular, and I've interpreted that same acorn in this fashion. It gives us a very jagged or aliased look that you would see in low-resolution graphic systems. And so here you have it. It's an interpretation of that same acorn, simply using right angles and trying to approximate that. Of course, the more right angles that I would put in there, right down to a single pixel level, would give a much rounder and fuller interpretation than I've given here. But I just wanted to get the point across that we would call this a sharp graphic or angular. The final interpretation that I've got here is rounded, where all of the corners are rounded, but not just arbitrarily rounded. They are rounded in proportion to the grid. And so therefore, if we're creating a radius of a circle, I'm just going to zoom in for this. If I were creating a circle using my circle tool, use the ellipse, the radius, if I start here, hold the Option key to draw from center, that's a radius of 1 pixel. And I'm just going to take it out to the outer edge. And for now, I'm going to just change this to a half point, just so we can see what's going on. And I'm going to go to the stroke menu here, and I'm going to ask that the stroke be apportioned and aligned to the inside of the path. And what this allows me to do is to adjust this path such that I just adjust it horizontally and vertically I know full on that the edges of that circle are touching the outside. I'm just going to change the opacity for a second so we can see the graph below. Change it to multiply. And you can see here that from the center of the circle to the outside is 1 pixel radius. And so whatever we were creating, whether that would be, let's just say, the arm of somebody, and this was to be the terminus of the arm, we would create it in this fashion. I'm just going to unite these two things together with our shape builder tool. And this, I've got a little bit of a deviation here, but you get the idea that any decision we make about creating roundness in our objects is always dictated by a circle of a very specific radius. If we were doing a much larger object, perhaps someone's head, then again I would use my ellipse in much the same fashion as I'd done before. And I'll just rearrange these things so that we're right on the grid. And that makes for a very tight rendering. And of course, my line width in this case would be 5 points. So that's my minimum. You can see the thickness is at least one of these grid pixels in width. Never any thinner than that. So that's 2.5 pixels in radius, if you think about it. Let's just change the blend mode. And you can see from the outside there's 1, there's 2, 2.5 pixels. And so this is exactly, now you're probably better using integers, so rather than 2.5, I could go in here to my menu under the properties of my ellipse, and I could give it very specific information here. And let's say we were creating a rectangle or a rounded rectangle, it doesn't really matter. And we're generating that rectangle in this fashion. I could give, I'm just going to change the blend mode so we can see the graph. Notice the stroke is on the inside, and then I could extend the properties here, and we can look at corner radius right here, and we can make them symmetrical or asymmetrical. If they're linked, a change in one affects a change in all 4 corners. If they're unlinked, they behave independently, and you'll notice I could make it a 5 pixel radius. In other words, 1 pixel on this larger grid. And I would just make that multiples of 5, because then I know that it becomes a multiple of the grid that I have down here, which happens to be 5 points per pixel. So let's just change that to 10. And you can see now that radius, if I were to measure from the center to the outside, 1, 2, each one of these being 5 pixels, that's a 10 pixel radius curve. So we need to control that curvature very exactly based on this grid system that we have down here, keeping in mind each pixel is the equivalent of 5 points or 5 pixels right here. So that's how you would construct it. And precision is really important. Keep in mind the minimum line width of 1 pixel on the grid, and keep the shapes simple, simple, simple.